Thanks, and also welcome from my side. I'm happy to present our service for collecting and providing web data for the social sciences. My name is Johannes Breuer. I'm the team leader of the Team Digital Society Observatory at the GESIS Department Computational Social Science, and my interests broadly cover the use and effects of digital media, digital trace data, and its use for social science research, computational methods, and meta science. And I'm presenting together with Dimi, who will introduce himself.
Yes, my name is Dimitar Dimitrov. I'm leading the team Information Extraction and Linking. It's part of the Knowledge Technologies for the Social Sciences, KTS department. Yeah, I'm interested in data science, natural language processing, and online discourse analysis in general.
Yeah, we're happy to have you here. And the agenda for our presentation today is, first, we want to give you a brief background on why collecting web data for social science research matters or is important and why we do it at GESIS. Then Dimi will introduce the GESIS web data service. And then in the last two parts of the presentation, we will present two exemplary data collections, current data collections or recent data collections each for what we call the long-term crawls or continuous data collection and topical collections. And Dimi will cover the long-term crawls for Twitter, now known as X, and Telegram, and I will talk about some the topical data collections that we have been doing for the EU election and the upcoming German federal election. Starting with the background, why web data matters and why we think collecting web data is relevant and important for social science research. We need web data to understand the evolution of the web and the internet itself, but also, of course, the human interactions that happen online that contribute to the web. And this is usually what social science research is interested in. Web data allows to measure naturally occurring human behavior, online human behavior, I should say, on a large scale and with great resolution, temporal resolution, but also the amount of detail that we can get on certain behaviors. We can engage in real-time data collections to collect the data when the behavior actually happens. And a lot of the algorithms or models that we now use in different parts of social science research, so for example on bot detection, political leaning detection, misinformation, and fake news detection, rely and are trained on web data. And of course the other way around also, this training data that goes into machine learning in general, but also specifically the large language models that are very popular and widely used now also in academic research, are based on web data, and that is created by users. So it's user-generated content, user interactions that are also the basis for these larger models. And all of that leads, and so it's not surprising that an increasing number of research studies and projects in the social sciences are using web data, so there's certainly relevance there. If we want to collect data, we are largely dependent on platforms. And probably many of you have heard about this, the Cambridge Analytica case, which essentially meant after data had been leaked or possibly misused, this was related also to access that academic researchers had to the data. Essentially, Facebook closed down large parts of its main API, its Graph API. So the data was not accessible anymore to researchers. Then a bit more recently, this change also took place at Twitter when it was renamed to X, and Elon Musk bought the company. Before, Twitter was fairly open and had very liberal data access for academic researchers, so it was used in a huge number of studies, but with the platform changing its name and its ownership, that API access has also been shut down. And it doesn't end there. Also Reddit, maybe a bit of a lesser known and lesser studied platform compared to Facebook and Twitter, but also Reddit had a fairly open API, and that has recently been closed and shut down. And the last thing that happened, there was this platform called CrowdTangle, maybe some of you know that, which is also a very accessible tool for accessing data from the Meta platforms, Instagram and Facebook, and that has been very recently shut down in August 2024. So that is one big issue, right? Why it makes sense to collect data, and also as an institute like GESIS to collect web data. But even if we had reliable data access by third parties, the data itself is not persistent. So We all know these examples, maybe from our own usage, but certainly as like consumers of content on social media platforms, that posts are deleted. They might be deleted, or accounts are deleted. This might be done by the platforms, for example, to stop malicious behavior or bots, but certainly also by users because they delete their content or maybe even their complete accounts. A very interesting study by Jürgen Pfeffer and colleagues shows that looks at data decay over time on Twitter. And this has shown that out of 16 tweets that are published, 1 out of 16 tweets that is published is not available anymore after 24 hours. And just begin to talk about how that changes over time. After 1 month, this data loss amounted to up to around 16% in their study. And this keeps on increasing, not linearly, of course, but still there is continuous data loss over time so that these data are not accessible anymore after a relatively short period of time. And what adds to this issue is that this is not random. So interesting study by Andreas Köpfer showed that this data mortality, as he calls it, or tweet mortality, is more pronounced for sensitive topics and sensitive studies. So imagine you study a topic like fake news or hate speech, then you will face even much stronger data decay and faster data loss over time. An interesting opinion or discussion piece that recently has been published by Brittany Davidson and colleagues hence argues that overall platform-controlled social media APIs are a threat to all principles of open science, because typically the APIs and the terms of service restrict what you can do with data, especially whether or how you can share them. And also, even if you could share them, we see that we have this data loss. Very often it's common practice. In Twitter, for example, it was only allowed to share the tweet IDs, not the actual tweets. So if you want to recollect them in a process that has been known as rehydration, if all of the content is deleted, the tweet or post IDs are of little use, so you cannot reproduce or replicate any of the studies. So this is the background against which we at GESIS have been developing the web data service, which Dimi will now introduce to you.
Yes, also welcome also from my side. I will show you the web data for the social science service. And yeah, this service acts actually as an umbrella for different activities around collecting digital behavior data. And yeah, we are looking especially to collect data from online platforms, including social media platforms. And yeah, the service is supposed to serve as an entry point to long-term samples from specific platforms like Twitter or Telegram that we consider relevant, and also provide data offers specifically prepared to enable research on current topics on societal relevance or acute events. This slide basically shows the components of the service. A big part of these activities that I mentioned are involved with community engagement. What we do is really we conduct surveys and collect the needs, the web data needs from social scientists. We monitor platforms, identify relevant platforms, relevant topics, and based on that, we conduct different feasibility studies that you see on the left in this web data collection component, where we also develop and evaluate collection pipelines, and we also develop these two directions of topical and long-term data collections, based on which we provide the data offers. This is the third component of the service, and to do this. To create these data offers, we do a lot of cleaning, pre-processing, and enrichment of this raw data that we collect, so that it fits the needs and requirements that we collected from the community. And we also conduct workshops, hackathons to really advertise the data and foster adoption. Yeah, the benefits of the service. Here, just probably the foremost most important that we consider. Johannes already mentioned this is independence of commercial third parties. The recent Twitter example is, I think, very prominent one. Then what we do is we really do continuous data collection. This means that we capture the data as it appears, and this basically helps with issues like post hoc data collection, where researchers collect the data after a certain period of time, and yeah, some posts or some data might not be available anymore. The third point that we think is very important is, yeah, researchers often are in small projects where they do not have the resources to collect data themselves, and especially they are not, individual researchers are not, or projects, they are time limited, and they cannot ensure that data can be collected over a long period of time and really made available to researchers. And this is something that GESIS can actually do. We can preemptively collect data and make it persistent and available to researchers. That's basically the last point here of on the slide. And like this, we can yeah, help with reproducibility and reusability. Yeah, data access. That's data access to the data offers that we provide is yeah, is structured along these three different types. We have free access, contract-based access, and secure data access, and these are levels of access that we provide based on the sensitivity of the data. And we also make sure that when we collect data, that we consider legal and ethical aspects. For example, yeah, Johannes already mentioned a lot of basically all the data that has been collected over the past years from Twitter, for example, was shared through the tweet IDs. Yeah, we were not allowed to share full texts. Yeah, and with that, I would actually go to the next point in our agenda, the long-term growth, and show you what we did on Twitter. Yeah, we've been collecting, or we collected until the API was closed, data from Twitter for 10 years, basically, using this 1% random sample API that Twitter offered. And this was real-time data collection where, yeah, the moment tweets basically appeared on Twitter, they were provided through this API. And we got really 1% random sample, independent of language, user, and such data to really, yeah, run such a data collection for so long period of time. That is technically challenging. That's why we wanted to avoid, for example, data gaps, and we had multiple crawlers on different locations. And the plot that you see here basically shows that we managed for 10 years to avoid basically data gaps. Now, based on this really big archive that we created by collecting the data from the 1% random sample API, we created a data offer called TweetsKB that is basically a subset of this 1% random archive containing 3 billion tweets that are pre-filtered. These are only English tweets. We tried to filter, for example, spam. And the data offer basically consists of the tweet's metadata, like timestamps, retweet counts, hashtag user mentions, and some pre-computed features that basically capture tweet semantics. So we offered their named entities, we offered sentiment scores for the tweets, geotags, and some science references or claims. This data offer really considers the terms of services of Twitter, where we don't share the full text, but through these pre-computed features, researchers are still able to do a lot of interesting research. Yeah, we have a website. You can go and visit that. Unfortunately, as Johannes already mentioned, the API was closed, so we have now very recently published our last release from TweetsKB that covers September 2022 until June 2023 when the API was closed. But yeah, the archive is very rich, and this is what we plan to do basically, is to create TweetsKB German, where we publish all German tweets, similarly enriched with entities and sentiments. And we want to, we have a collaboration with the German National Library where they will basically reuse this data enrichment pipeline that we created, and publish also their tweets, German tweet collection, using this same pipeline and format. And yeah, now that the API is closed, what can we do? How can we enable social scientists to replicate such research on other platforms? And this is a recent paper that basically analyzed the number of publications published in sociology venues in the last years, and calls for replication of this research on other platforms. And one platform that we think is very relevant is Telegram. And there are natural questions that arise there when we think about data collection. So what data is available? How does it map to Twitter and X? What's, for example, a retweet on Telegram? Yeah, is it even available there when we download the data? With that, I would go to the next data or long-term crawl that we have about Telegram. Short intro of the platform, or the Telegram messaging. It's a messaging app similar to WhatsApp. It has more than 700 million users. It gained popularity for its privacy features, but has also some social network features like groups and channels. And what's really nice, it offers an API. That's really nice for us. Now I would like to show you a bit more how Telegram looks like. So you have these groups. They can be private and public. Every member in the group can write into the chat. Often it's known who is the administrator, and often it's also possible to access the members list. On Telegram, we also have channels. They can be also public and private. But in channels, only the administrator can write a message. Often it's not known who is the administrator, and only the members, the number of subscribers are disclosed. Now, how Telegram maps to Twitter. Here on the user level or channel level, we see that there is basically one-on-one mapping. We have a description, we have the followers. That's pretty nice. If we look at the message level, we see, the message is there, very similar on Telegram as on Twitter. We have the metadata, the number of views and when the tweet was posted, or a message on Telegram was posted. We have the reactions, and we have replies. That's also very nice. For Twitter, we have the retweets, but on Telegram, this number is not directly available, although you can forward the message. So that's the difference here. Now, how do we collect actually data from Telegram? I mentioned there is this API, and you can use that to download data from there, but Telegram is organized very differently compared to Twitter, and in particular to this 1% random sample API. And to start collecting data from Telegram, you need to know the channels. And there is no repository of channels, no official repository of channels, but there are websites like TGStats that basically provide an overview of available channels and different rankings for them. For example, subscribers, citations, and reach. And this is what we actually did. We went to this website, collected the top 100 channels in each category, and started downloading the data from there. Every time when we download the data from a channel, we looked whether there are forwarded messages in this channel and to which other channels these messages were forwarded, and we basically extended our seed list of channels for data collection with these newly discovered channels. And this process continues like this, and we discover constantly new channels and scrape them. Now, how do we shape a data offer based on this long-term crawl? We thought about data offer that has basically two components. The first one is the channel-to-channel graph, where we have the channels as nodes, and we have an edge between two channels if a message was passed between these two channels. On the other side, we see this message forwarding chain, and this basically represents how a message was passed through Telegram. And you see here there are different colors for the nodes. They basically indicate whether a channel is private or public. And naturally, when we hit a private channel, we don't know how the messages travel further. That's how it is basically. Now, some statistics about this channel-to-channel graph that we have. We cover already more than 100,000 channels. We have more than 1 million edges. The total number of messages that are passed are almost 30 million, and or more than 8 million are unique messages. We see that we have around 43% of private channel in this data, and that the average number of transmitted messages is between two channels is 270 almost. These are just some of the use cases for this data set. You can do network analysis, content analysis, you can do behavior analysis, see, for example, channel interactions over time. The last or the second component of this data offer is basically this message forwarding chain. And we see that on average, a message is passed 2.5 times, and the maximum number of hops that we have in this chain in our data set right now is 303,000, a bit more than 303,000. And some use cases also for this part of the data offer. You could really track and trace message flow, identify the origin of message, how they are spread across Telegram. You can analyze forwarding patterns, spot trending topics, and investigate harmful content, for example, how toxic messages spread. And with that, I would actually hand over to Johannes.
Thank you. After Dimi has introduced you to the long-term crawls, I will now talk about the other type of collections that we have in the service, which are the topical collections. The first topical collection that we did was for the European Parliament election this year. We collected data for all the German candidates who were running for the EU Parliament. The study was done in close collaboration with the German Longitudinal Election Study, or GLAS for short. If you don't know this, they always do this so-called candidate survey, in which they conduct surveys with the candidates who run in the election. And what we want to provide is data that can be linked with the survey data. We included a number of different platforms or data sources. We have data from Twitter, Facebook and Instagram, TikTok, web search data, and the candidate websites. In terms of the time that we covered, we have data from April 1st until 2 weeks after the actual election, which took place on June 9th this year. So this is the basis that we have. There's this candidate information dataset, and this has already been published, which contains some basic info that has been compiled largely by the GLAS team with some support from us. And this contains the basic information about the candidates, so their names, which parties they were running for, etc. And now it also has information on their social media accounts. It includes information for 1,044 candidates. Within that, we identified 428 Twitter accounts, and just to give you a note, we searched for up to 2 accounts. So if a person had multiple accounts, both were included in the collection. This is why this is not a one-to-one match between the identified accounts and the number of candidates. For Facebook, we have 719 accounts, so that was the most widely, or that was the platform on which most of the candidates had an account, followed by Instagram with 660 accounts, and then TikTok with 208. And having a personal website related to, potentially related to the campaign was the case for 215 candidates in the EU election dataset. What do we actually collect and how do we collect it? For Twitter Next, we collected data on the profiles of the candidates and also the posts and the metadata. So essentially what Dimi just showed you, right? The number of likes, retweets, etc. All of these popularity metrics, if you will. How do we do it? We used web scraping and worked with the paid API because this free academic API, as we discussed before, unfortunately doesn't exist anymore. For Facebook, we also have information about the profile of the candidates and their posts on their public profiles, again, with similar metadata, number of comments, number of reactions, etc. And we also collected data on ads that the candidates ran during their campaign. And for those ads, we also have metadata like content. We have the content, but we also have metadata like the impressions, the spending, and if they used targeting criteria for their ads. We collected these data through CrowdJungle, which now, sadly, it doesn't exist anymore, and the Meta Ad Library, which is one tool that actually still exists. For Instagram, we did pretty much exactly the same sources, same types of data as for Facebook. For TikTok, we used a scraping approach to collect information about the profiles and also the metadata for the videos, if the candidates posted videos themselves. For web search, we used a tool that has been developed here at GESIS called the WebBot tool, which essentially is a simulated browsing approach. We focused on Google search results mostly, so both search and news results, as well as the suggested additional search terms for a combination of the candidate and the party name. And the websites, we just essentially collected the full HTML. The ones that are bolded here, I will talk about in a bit more detail on the following slides. So Twitter, Facebook, Instagram, and TikTok. Yeah, what does the data look like? Just a very coarse summary of the data. For Twitter, we have 292 or 305, depending on the approach, accounts, and a total number of unique tweets around 35,000. That includes retweets by the candidates. For the Meta platforms, so Instagram and Facebook, for the ad data, we have 37 accounts. We also included the national, or if they exist, EU-level party accounts, so not the subnational or local party accounts. We have 515 ads from the candidates themselves, and kind of as you probably know or would expect, we have the parties themselves ran many more ads than the candidates. We have a bit more than 2,700 ads from those party pages. From Facebook, we have data from 201 accounts, amounting to a bit more than 8,000 posts. Instagram, 453 accounts, a bit less than 12,000 posts. TikTok, 140 accounts, and a bit less than 4,000 videos, so metadata about individual videos that have been posted. Regarding the plans for data release, we are currently working on creating an aggregate data set that has aggregated per candidate data. And hope that this can be released alongside or very briefly after the survey data from the candidate study, so that it can be linked with the candidate study data on a candidate level. So the next thing that's coming up in terms of topical collection for us is the German federal election. And I guess you've all been following the news. So our plan was that we have some time, and now we will prepare the data from the EU election and publish it, and then, well, reality overtook us, and now we have to kind of speed things up and reprioritize stuff. So it's a bit of a hectic time at the moment for us, for many researchers, many other people, politicians probably, especially campaigners. But still, our intention is to essentially repeat what we did for the European election, also for the federal election. We now know that the early elections, and this has been, I think, announced yesterday, so apologies that I didn't put the exact date, but most likely, I think, February 23rd is the election date that we'll have. So we have much less time to create this candidate list. Of course, the candidate list has to be released by the Bundeswahlleitung, or the official one. So we have very short time frames for this, and also for finding the social media accounts, and also for applying for data access for these, because with the introduction of the Digital Services Act, the DSA, most platforms now have some sort of academic data access program again, but those require applications, and this takes time. So yeah, time is of an issue here. CrowdTangle was shut down, so we need to find a replacement. So how do we want to tackle this? We are in talks with other collaboration partners, other researchers, other institutes to distribute some of this workload in the given short period of time. We will apply for the Meta Content Library, which is the new access platform that is supposed to replace CrowdTangle, even though it's different in many ways. And the Digital Services Act application forms that Twitter and TikTok offers in various forms. Yeah, and possibly, depending on how all of this turns out, we might not have the full list of data sources that we had for the EU election, but that's to be seen in the next coming weeks. And just as a final thing, we mentioned these three components of the service. We talked about the data collections and data offers, and specifically these two types of data collections, the long-term continuous crawls and the topical collections. But we also do community involvement. We have done some workshops and shared tasks at various events previously, and we will do further ones at different conferences, trying to cover the range of social sciences, computational social science, and also the overlap with computer science, where also social science research is done or collaboratively done in the future. So keep your eyes open for that. And Demi briefly mentioned the community needs survey, which we are still conducting. So we'd be very happy. It really takes 5 minutes. It's only about gathering people's input on what types of data they're interested in, what they need for their research. So to make your wishes or heard, it would be really great if you could fill this out. You don't have to do that now. The slides will be shared. It takes 5 minutes. It's a really short Google form questionnaire that is very easy and quick to be filled out. If you want to, you can take a photo of the QR code or note down the link, but we will share that again later, and we'd be very happy to have your input that we can use for the development of this service in the future. Yeah, and talking about input, that's the perfect segue to ending this presentation. We'd be really interested in your comments and questions about the presentation, about the service, and any other thoughts or ideas you might have. And yeah, thank you for your attention. Look forward to the discussion. Thanks.